Okay, so now I am going to discuss part C numerical question, and here is the question 1. A thin uniform steel chain is 10 meter long with a linear mass density of 2 kg per meter. The chain hangs vertically with one end attached to a horizontal axle having a negligibly small radius compared to its length. What is the work done in Newton meter to slowly wind up the chain on the axle? The acceleration due to gravity is g equal to 9.8 meter per second. So let's draw the figure. If this is a horizontal axle, then one end is attached to a horizontal axle. So one end is this is a chain which length is 10 meter, and if this is the total distance is y, and if the small elementary is dy, then we can write that the mass of the small elementary equal to dm, which is m by l dy, and we know that linear mass density lambda is m by l, which is lambda dy. So they have asked that the work done to slowly wind up the chain on the axle. So work done to slowly wind up the chain equal to potential energy of the chain. So we'll find the potential energy. So for potential energy, so dw is dmgy. So we can integrate this. So dm is lambda and lambda dy, so lambda g y dy, 0 to 10 meter long. So this is w and this is lambda g y square divided by 2, 0 to 10. So lambda is 2, g is 9.81 into 10 square divided by 2. So this will be 9.81 into 100, which is 981 Newton meter. So this is the answer. Here is question number 2. A one-dimensional harmonic oscillator is in the state psi equal to summation of n equal to 0 to infinity 1 divided by n factorial root over of n factorial n ket, where n ket is the normalized energy eigenstate with eigenvalue n plus half h cut omega. Let the expectation value of the Hamiltonian in the state psi be expressed as half alpha h cut omega. What is the value of alpha? So the state is psi ket is summation of n equal to 0 to infinity 1 divided by root over of n factorial n ket. So n is already normalized energy eigenstate. So expectation value of h is psi bra psi h ket psi. So here summation of n equal to 0 to infinity 1 divided by root over of n factorial n. So we can write 1 divided by root over of n factorial n plus half h cut omega summation of n equal to 0 to infinity 1 divided by n factorial So we can write that n equal to 0 to infinity n factorial n plus half h cut omega. So n equal to 0 to infinity, this is n by n factorial plus summation of n equal to 0 to infinity half of 2 into n factorial h cut omega. So we can simplify this expansion. So we can write first, this is 0 by 0 factorial plus 1 divided by 1 factorial plus 2 divided by 2 factorial plus 3 divided by 3 factorial plus 4 divided by 4 factorial and so on, plus one by 2 is common, so 1 divided by 0 factorial plus 1 divided by 1 factorial plus 1 divided by 2 factorial plus 1 divided by 3 factorial and so on into h bar omega. So this is 1 plus 2 divided by 2 plus 3 divided by 3 into 2 factorial plus 4 divided by 4 into 3 into 2, so on. So 3 is cancelled out, 4 and here 1 divided by, this is basically e h cut omega. So this is 1 plus 1 plus 1 divided by 2 factorial plus 1 divided by 3 factorial plus half e h cut omega. So this is also e, so e plus half e h cut omega, so 3 by 2 e h cut omega. But the answer key is 3, so in this question maybe they have skipped the e part, so I think the answer is 3. Now question number 3 is, the Euler polynomials are defined by 2 e to the power xs divided by e to the power x plus 1 equal to summation of n equal to 0 to infinity ens into x to the power n divided by n factorial. What is the value of e52 plus e53? So first, 2 e to the power xs divided by e to the power x plus 1. We'll simplify this one first. So 2 e to the power xs divided by, if we take e to the power x in common, then this will be e to the power minus x plus 1. Okay, so 2 e to the power xs into 1 plus e to the power minus x inverse 1. So this is 2 e to the power s minus 1 into x, and this will be 1 minus e to the power minus x plus e to the power minus 2x minus e to the power minus 3x plus e to the power minus 4x minus e to the power minus 5x plus so on. So this equal to, so we can write this, that 2 into e to the power minus e to the power s minus 1 into x minus e to the power s minus 2 into x plus e to the power s minus 3 into x minus e to the power s minus 4 into x plus e to the power s minus 5 into x minus e to the power s minus 6 into x and so on. So we can write e to the power s minus 1 into x is that s minus 1 to the power n into x to the power n divided by n. Sorry, this is summation of n equal to 0 to infinity. Just like that e to the power x is summation of n equal to 0 to infinity x to the power n divided by n factorial, just this, minus s minus 2 to the power n x to the power n divided by n factorial plus s minus 3 to the power n x to the power n divided by n factorial minus s minus 4 to the power n x to the power n divided by n factorial plus s minus 5 to the power n x to the power n divided by n factorial minus s minus 6 to the power n x to the power n divided by n factorial, and so on. So this is basically this, which is summation of n equal to 0 to infinity e n s x to the power n n factorial. So if we compare this two things, then we can write that e n s is 2 into s minus 1 to the power n into, okay, so s minus 1 to the power n minus s minus 2 to the power n plus s minus 3 to the power n minus s minus 4 to the power n plus s minus 5 to the power n minus s minus 6 to the power n, and so on. Now the question is that e52 plus e53. So e52, so e52, that means n is 5 and s is 2. So e52 is 2 into 2 minus 1 to the power 5 minus 2 minus 2 to the power 5 plus 2 minus 3 to the power 5 minus 2 minus 4 to the power 5 plus 2 minus 5 to the power 5 minus 2 minus 6 to the power 5, and so on. So this is 2 into 1 to the power 5 minus of 0 to the power 5 plus minus 1 to the power 5 minus minus 2 to the power 5 plus minus 3 to the power 5 minus minus of 4 to the power 5, and so on. And now e53. So here n equal to 5 and s equal to 3. So for this e53 is 2 into 3 minus 1 to the power 5 minus 3 minus 2 to the power 5 plus 3 minus 3 to the power 5 minus 3 minus 4 to the power 5 plus 3 minus 5 to the power 5 minus 3 minus 6 to the power 5, and so on. So 2 into 2 to the power 5 minus 1 to the power 5 minus 1 to the power 5 plus 0 to the power 5 minus of minus 1 to the power 5 plus minus 2 to the power 5 minus of minus 3 to the power 5, and so on. So just e52 plus e53 is 2 into 2 in common basically, so 1 to the power 5 plus of minus 1 to the power 5 minus of minus 2 to the power 5 plus of minus 3 to the power 5 minus of minus 4 to the power 5, and so on, plus 2 to the power 5 minus 1 to the power 5 minus of minus 1 to the power 5 plus of minus 2 to the power 5 minus of minus 3 to the power 5, and so on. So here this term and this term will be cancelled out, this and this minus of minus 2, minus of minus 3, and this will also be cancelled out when the extra term will consider. So here only 2 to the power 5 will get only 2 to the power 5. So 2 into 2 to the power 5, which is 2 to the power 6, which is 64. So the answer is 64. Now question number 4 is, what is the angle in degrees between the surfaces y square plus z square equal to 2 and y square minus x square equal to 0 at the point 1 minus 1 and 1? So first, the equation of the surfaces is f1 is y square plus z square minus 2 and f2 is y square minus x square. So first, the normal to the first surface is, so normal to the first surface is grad f1, so which is del del x plus j cap del del y plus k cap del del z y square plus z square minus of 2. So this is 2 y j cap plus 2 z k cap, and grad f2 is 2 minus of 2x I cap plus 2y j cap. So we know that grad of f1 dot grad of f2 is mod of f1 grad f1 into mod of f2 into cos theta. So cos theta is f1 grad f2 divided by mod of f1 mod of grad f2. So this is 2yj cap plus 2zk cap into minus of 2x y cap plus 2yj cap divided by 2y square plus 2z square into root over of minus of 2x square plus 2y square. So they want the angle at the point 1 minus 1 and 1. So cos theta at the point 1 minus 1 1 is, so y is minus 1. So 2 into minus 1 is minus 2j cap plus 2k cap dot minus 2I cap plus 2 into minus 1 j cap. So minus 1, that means 4 plus 4, and it's also 4 plus 4. So we'll get, this will be 0 and this will be 0, and minus 2 j cap minus 2 j cap. So this will be plus 4 divided by root 8 into root 8. So 4 divided by 8. That means theta is cos inverse 4 divided by 8, which is cos inverse half, and cos inverse half is 60 degree. So the angle between the surfaces, at the point is 60 degree. Now question number 5. Consider a system of 15 non-interacting spin polarized electrons. They are trapped in a two-dimensional isotropic harmonic oscillator potential Vxy equal to half m omega square x square plus y square. The angular frequency omega is such that h cut omega is 1 in such chosen unit. What is the ground state energy system in the same units? So Vxy is half m omega square x square plus y square. So this is two-dimensional isotropic harmonic oscillator, and for two-dimensional harmonic oscillator the energy is E nx ny is nx plus ny plus 1 h cut omega. We know that for E nx equal to half plus nx h cut omega, and E ny is half plus ny h cut omega. Now they have asked that 15 non-interacting spin polarized electrons okay, so when nx ny is 0 0, here is one polarized electrons, when and here degeneracy is 1. In the first excited state, here nx ny is 0 0. Okay, so first excited state, this is 1 0 and this is 0 1, and degeneracy is 2, and here is one spin polarized, here is also 1. Okay, in third state, in this is 3 degeneracy, so this is 1 1 0 2 and 2 0. In fourth state, we can find that degeneracy is 4 and 1 2 2 1 3 0 0 3, and in fifth state degeneracy is 5, so 2 2 3 1 1 3 4 0 and 0 4, and so 1 2 3 4 5 6 7 8 9 10, and this is 5, so total 15 electrons. And spin polarized electrons means that the direction of the spin is fixed. So now we'll calculate that energy E is, so here degeneracy is 1, so 1 into h cut omega plus 2 into, this is 2 h cut omega plus 3 into 3 h cut omega plus 4 into 4 h cut omega plus 5 into 5 h cut omega. So h cut omega plus 4 h cut omega plus 9 h cut omega plus 16 h cut omega plus 25 h cut omega, which is 55 h cut omega. So the answer is 55.